Okay, hope still works. So again, so what is Mila? So the idea behind Mila is that there's a lot of stuff that people just don't have time for it, or they don't have the skills for it. And with Mila, you can find a technician in your neighborhood that will help you solve the problem. So it can be setting up a TV, or if you have problems with, let's say, with a laptop, you want to set a laptop, you can hire a Mila technician, and we are the marketplace to find one. So I know that, for example, you are one. That's and so we have technicians like that. And so what we do is like we do the entire software to handle those cases. So we handle the payment stuff, the ratings, finding of the partner. We have a matching algorithm that will help find the partner that is like in the neighborhood, that has the right skills and that has good reviews. So this is what Mila is doing. And what we have is that, so let me maybe show the start page. So when you go to the Mila starting page, that's the browser. So anyway, so we have some offerings. So for example, you can say I want to set up, let's say, Wi-Fi at home, and or I have a large home with, and I need to set up a repeater. So we need to provide a search possibility for our customers to find the right offerings. There are different ways how we can achieve this, but one of the possibilities that we have is via a full text search. That is like we have a full text search on the description of the packages, and this is where we use Elasticsearch. So maybe what's the architecture of the Mila.com page that we use? So we have a pre-rendered React single page application. We have a lot of products and a lot of, let's say, sub pages on Mila.com. But if different people go to the Mila page, they will see exactly the same thing. So it's not like the Gmail where you will see your personalized content there. Very often it's the page that everybody will see exactly the same content. So that's the reason why we decided that we go for a pre-rendered React application, which makes it that the site can be really fast, and it's also like advantages for indexing by Google. On this Mila.com page, what we have is like we have the search, and we want to provide the full text search to our customers so that they can find it. But at the same time, we don't want to expose Elasticsearch to the world. So we don't want to that the single page application is calling Elasticsearch directly. And what we also don't want is that the single page application has to build the query and take care of the indexing of the packages. So that's why we decided to have a microservice that will take care of those tasks. So this is the rough overview of our architecture that we use. So on the right side over there, you see the Mila.com, and finally it goes to our search service. The search service here, and looks and specifies some terms you want to look for. This is coming out of the search window, and it goes to the search service. And finally, the search service, this is like the internal service that takes care of it, that tides await the Elasticsearch. It then goes and queries Elasticsearch, and of course, like here you see, it's a very simple, let's say, term search here. It's transferred into an Elasticsearch query in the background. So whenever we change the query, whenever we change something to the data structure that we have, it's hidden away by the search service, and it's the front end that doesn't have to take care of this. And other responsibility of the search service is that it indexes the data that we have. So we have backend systems, we have that are abstracted away. We have a GraphQL interface, and through this GraphQL interface we can get all the data about the different offerings that we have, about all the things that we want to index. So the responsibility of the search service is to grab the data from there and to index it in Elasticsearch. And this is happening currently as a periodic job, and there are some areas of improvement that I will show you later how it can work. So now, as I said, another responsibility also of this search service is not just querying and indexing the data, but what we also do is like we enrich and adapt the results. So for example, if a user doesn't find anything using his query, we want to return him some general offerings that they can, for example, you search for a term, I want to set up, let's say, Apple TV, and it may happen that we don't have Apple TV in the offering, then we want to return him like a general support package where the user can just book this, and we'll find a support for that. And so this kind of stuff can be done or is done within the search service. So the search service adapts and changes the results based on the situation. And for us, it's much easier to do this in this part rather than in Elasticsearch to change the results when they come. Then what's also done in this Elasticsearch service is that the structure, meaning the mapping of the data, is defined there as using a Python library, the Elasticsearch DSL library, and it's happening in this microservice. So we don't have to issue the mapping as a JSON to push it into Elasticsearch, but it's via this Python service that we can define it. I will just after this slide show you how the code looks like, and it makes the things easier to manage. And as I already mentioned, we get the data from the GraphQL backend, and finally we index it in Elasticsearch. So far, do you have any questions for the setup? Yes?
How many packages are there? Is it millions or tens or hundreds?
Yeah, so we don't have so many, like we have maybe 200-300 packages that we have. We also have like specific packages. For example, you can book a, let's say, setup of a Wi-Fi router that is a Swisscom variant, or for example, Salt or Brac, and this makes it like this. That's the reason why we have so many packages. But we're currently working on reducing that number so that it's easier, like accessible to the people. They can configure a package with different options. But currently, like there are a few hundred, so it's not really like. It's not the same requirement like in a big shop where you have like hundreds of thousands of packages. So here, like it's a small number, relatively small number. A package is, for example, setting up the computer list. So a package is an offering, so that people can see, like, for example, oh, I want to set up a Wi-Fi router at home. This is a package. So it's like an offering. And it's like, of course, that's a question like, is this understandable for people? And sometimes it's not. So at Mila, we're trying like to figure the right way how people can understand what we offer.
And how large is the data?
Sorry?
How large is the data that you're searching?
So the description of the package is maybe like a fourth of an A4 page. So it's not that much. So it's a description like, for example, troubleshoot my Wi-Fi router at home, and I have like multiple pieces, and so this.
So the database, which is at some point, I say, so PostgreSQL. So what is the size of data? Is it in gigabytes or terabytes?
So.
I understand it's small.
Yeah, it's.
Megabytes, I guess. So then why do you need Elasticsearch?
Why do we need Elasticsearch? Because it's like in this case, so of course, like the data that we're searching with Elasticsearch is really a small set, or like in terms of size and how many, let's say, items of information there are. But it's like, for me, it's a very a nice solution, an easy solution to have like full text search with synonyms, with all the features that Elastic brings when it comes to full text search. And of course, there's maybe you could use likes in SQL, but it's like, for me, it's a nice solution for full text search, even if the set is not that big. And like in terms of other data that we have there, so we have all the data for the cases. So we have several thousand like of bookings per month, and all that's like, let's say, handling of those cases generates a lot of data. But that's another part, and we are thinking of how we can leverage also Elasticsearch and the mapping the matching possibilities for the matching algorithms. But we are not there yet. We are doing some experiments. So, but it's not yet in production. So I mentioned the Elasticsearch DSL library, and it's a great Python library if you want to interact with Elasticsearch. And I will show you like some parts of it that we use. So this part is here you can see I can define, this is the offering that I defined, and it's a document. So here I can define the structure of the documents that I want to index. And in this case, you will see that I have some properties and some EP slug here. And this is the the DSL that offers you like that. You can define the structure of it, and you can see that there are some special stuff. So, for example, we have some fields here. We have the raw, that's the keyword, and we have a text with a specific analyzer. So in Elasticsearch, you can use this library not only to define the structure, but also if you have special requirements. For example, in our case, I don't know whether you know, there are Lumimart shops that sell lamps. So there are smart lamps and lamps that require support when you install them at home. So we also work together with Lumimart, and they have product IDs with dots. So one of the requirements was that in order to make it faster for the employees, you can enter the product ID without the dots or with the dots, and it should match, however. So I had to define, that's a small thing, so I defined a small filter here. That's the dot strips filter that will get rid of the dots, and this is like how we index the data here. Of course, there are different ways to do this, but that's just the way that we've chosen here. And then you can define your specific analyzer, and you can then finally, when you define the mapping of the document here, you can use the specific analyzer that you defined. So how many of you use specific analyzers or specific filters when it comes to indexing data? Okay, and where do you use it? Or how?
Well, one of our projects involves kind of the same thing, product IDs, which have like dashes in there.
Okay.
Exactly the same thing, actually.
Okay. And how do you define the mappings?
In this, I wouldn't recall, but I think we defined it using JSON.
Okay.
And we define it on like when we create the index.
Yeah.
So when you define a mapping, you do it only once. In that case, I mean, even as you say, if you write it as a JSON and fire it once, what would be the purpose to set it up using Elastic DSL, using this package?
What's the purpose? So here so in fact the Elastic DSL library, it's not only a library. So maybe in this case, maybe you could argue that it's an overkill, but I think it's prepared, like, so let's say it's prepared for some cases. So it's not only for indexing data, but you can also use the library to search data. You can use this library to do certain queries, and you will just see an example how we do it here. So it's not just indexing, defining the mappings, but also searching the data. And what we also do is the bulk indexing of data, and also like when we update the index. So whenever the product, let's say, information changes, we want to reinsert some data, and currently like we cannot like detect, we're working on this, but we're not detecting when something changes. So we basically periodically like replace the index with a newly indexed data, because we don't have so many items here. And so every time you have to install the mapping, or like insert, like put the mapping. And of course you could use JSON, but it's like here you just directly have Python to define it, and so it's in the code. I think it's like you can use both. Yeah. Yeah.
So you have this periodic job which updates the data, and whenever you update the data, you also set up a fresh mapping.
Exactly.
Okay.
Yeah. And of course, like if you have a JSON, then you still have to maybe take the request library. So if I want to do this in my search service, I would have to take the request library. I would have to read the JSON and also like put it like that. So it's like here I can define it in Python, and I can just say, okay, please init the index, and that's done. Yeah.
So how do you deal with like mapping changes or changes to your filters? Do you do like do you use the reindex API, or do you
Okay.
like create fresh index?
Yeah, so we don't have so much data here, and I will just show you like what's the idea, that we have like a instantaneous switch between the like a new and old index, but we basically re-index all the data into new index, and we can switch to the new index. So that's how it works. Okay, so I think it's not really doable if you have like millions of documents, because you cannot re-index them all the time. But in our case, that's really not a problem, so we can use the simple approach here. I think that really depends on the use case that you have. So I was already mentioning, so finally, that's a short part of the mapping. So you see exactly this mapping is produced out of my Python code. And so you already saw this here. I defined the filters and the analyzers. And so within this within this or with this library, I can also like define queries like that. So you see here I have a few match brace prefix queries, and I can search on the data and apply some manipulations here, and this is also like covered by this library. So there's some basic search functionality, and you can build your queries as you wish. And this is the part, well, of course it's difficult to read the code just like that, but this is the part where if we don't find anything, we add some basic results like some general support packages, because we know that this is some kind of a fallback that we have. And I can do all this kind of manipulations in this search service using this library or extending parts of it.
How is it served?
So
Library
to the front end.
to the front end.
So here I use a simple Flask server, and I have an extension, I think that's called REST API, where I expose exactly the results of it as a REST end. Yeah, exactly. It's a tiny server, and the nice part of it that it's stateless, because it's just serving the data from Elasticsearch. So if necessary, I could have a bunch of them or without state.
Is the library provided by Elastic, or is it like
Which one? Flask.
no, the Elasticsearch?
It's an Elastic project.
It's an Elastic project, yes.
Is there any benefit of using this one against the Node or the Java client or whatever? I think Elastic offers different.
Yeah, I think you can find it in any language. So whether there's an advantage, yes, because I like Python, so that's the advantage.
But for example, the Node client is just a client, so you still have, because that's what we're using. You still have to build your queries and send it to that. You have to like create a structure. You don't have like classes and stuff like that. There are projects for Node that are doing that, but we found out that some of them are like outdated. You don't get the latest features that by us if it's called like Elasticsearch.
I think this one is pretty like updated, and it's like sometimes, like for example, years ago, I started to use Haystack, and it's a Django extension to also to access Elasticsearch and other search let's say servers or libraries. But the problem with this is it was always lagging behind. So whenever you had a nice feature in Elasticsearch, it was not in Haystack, so you had to build workarounds. And Elasticsearch DSL is built specifically to access Elasticsearch, so I think it's pretty like in line with the offering, like with the things. And if there's anything missing, you can easily extend it and add requests, whatever you want to.
Is it kind of a best practice or just a personal choice?
You mean Elastic DSL?
The way you do it. Is it
Mm,
only the best
that's
practice
maybe
or
a question that those two guys could answer better, because I know that they are, for example, I don't know whether it's called like that, but there was Elasticsearch Shield. So for example, so that's the idea that you have like somehow plugins and add-ons that you can expose Elasticsearch to the outside world. So that's, for example, nobody can delete your index from the outside. I don't want anybody to do this, so I just expose very simple endpoint where you can search for the packages that we have, and like anything else, like the management stuff, getting in and like searching, like free searching is like hidden, so it's not even available through my service. But using shields, you might probably have some kind of a security protection. I don't know what's somehow the best practices for SPAs to access it.
The simple answer is it depends. It's one of our core values, because it's like programming language, frameworks. Everyone has a preference. They're good for some projects, not for other projects. So I don't think there's a right or wrong here. Like, you could argue hours about it. Is Python and Node.js better?
Yeah.
Doesn't matter.
I just thought about the library that's provided.
Yeah.
Any library that's updated frequently.
Yeah, so I can comment. I think the message here is we have by now a full-time client team. Actually, people working full-time on the clients, which wasn't the case in the past. So I would say the libraries that are built by Elastic are guaranteed to also work
Okay,
with the new
that's all I need to know.
Right.
And from my experience building those specialty queries, building them like in some JSON library, it's nice to have a decent library to build all the queries. Because otherwise you're always like looking up like how exactly has the JSON to look like, okay, and
now build it up in my programming language, which might have not the
Yeah.
super duper JSON library, and then it's
That-
very nice to have just like
I think that's a very good and strong point. So that's like if you use this Elasticsearch DSL, you can write the queries that you build are much more compact than if you like build them in JSON. And if you want to refactor anything, it's like much easier to refactor. So I think that's why I prefer this. Whenever it's possible to do this in this way, I prefer to do it this way.
Would there ever be a pure client library? I think there is
There
a
is,
low
there
level.
is, yeah.
So
Yeah.
originally, all clients were low level only, and they have the same test suite. They are the same, like the DSL or .NET high level. I actually built Elastic at the PHP one, which is still not official, but it's used a lot. So that is actually, I mean, built also a high level client, which is not officially supported, so I don't use it. No, but we
PHP one.
huh?
PHP one.
The high level Elastica, my client, I mean, I still do it on the side, but I'm unemployed for the client. So we get more and more these high level clients. It's just, I would say, more work because you always need to keep up with everything will change in Elasticsearch. So if there's a new feature, you need to do some new proxy methods and so on.
And
But yeah.
these high-level clients are also more native to the language that they are in. Like the Elasticsearch DSL, if you ever programmed with Django, it looks super familiar. Like the queue things for creating queries and combining queries, that's basically what the Django ORM does. So if you've done that, then you know how to use Elasticsearch DSL to a certain point. .NET has different concepts, so those high-level or that high-level client has to adapt to those concepts and not to something that an ORM in a different language does. It's more difficult to have like a common feature set, but we try to be more native to the environment that clients have.
there was no first fall was like a JavaScript library for the browser could use because with the spec I can
I expect.
distinguish user roles and say okay connect to it, and if it is not critical, just a few fields, it would be very easy to put it in my website, configure the JSON, and the search it would be a very easy approach.
Yeah.
But
I mean, there is a JavaScript.
Yeah, but
Yeah,
it's
it's
built for Node.
it's built for
But,
Node, you know, you need another server.
I fully agree. Like you could probably do this query within the single page application, but I would still have to take care of like indexing the data, of some job doing this and handling, and also like,
Good point. That's a good point.
and I would also have to take care of like somebody would have to write this query in the front end, and we already had this front end, and I said I will take care of the search because I still want to do some programming and not just.
I'm not sure if I would want to expose my Elasticsearch server directly.
No, I wouldn't either, but you can put something in front of like a load balancer or something else.
Exactly. So this is this in front of that. Yeah.
And I mean, like the issue for us was like why we didn't do that was because like you can do like really complex queries with install your Elasticsearch cluster if you just like have that in public.
Yeah, this is a good reason.
Yeah. So
Not to
that
do it.
that you shouldn't do that, I
Okay,
guess.
okay.
And so here in this case, so we only have the front end that is accessing this search, but we probably will have like an internal tool and a tool for our partners that will also do some kind of search, and then all the tools would have to rebuild the same search functionality, and like this you have like exactly the same behavior for whoever is consuming it. That's also one of the points. And so what you see here is what you see here is I was mentioning the GraphQL endpoints that we use like to aggregate data from different sources, and in the search service I actually have a GraphQL query that I use to get the data that I want to index in Elasticsearch, and then I use a bulk approach to load this data into Elasticsearch. So as I said, so we still have some areas for improvement, and this is really work in progress now. So we currently have like there is somehow the periodic job that goes over the data and loads it into indexes, and one of the improvements that we will do is like we will have a let's say a read and a write alias, and with the aliases you can really have like this interruptionless possibility to change the index with another index. And I only have like maybe So I have a read and write alias, and they point to actually to an index. So with let's say products with a timestamp, and so the read and write normally point to the same index. Whenever I want to update the index, so I want to reindex all the data, I can create a new index here with the next timestamp, and I then point this products write alias to the new index, and I index the data into the new one. And then once all the data is written, then there I can switch the read index to the new, and I can delete the old index. And like this, you have really nice built-in mechanism in Elasticsearch, so that you can do this changing of the index and not without an interruption. Yeah. So I just don't know what time is it now? So it's time to end, I think.
I mean, depends on.
Yeah, so it depends. So that's my basic talk that I prepared for today, and I thought like if you somehow interested in the basic mechanism of full text search, I have some few backup slides. I don't know whether you're interested. Shall I show a few slides so we can maybe have it more as a discussion, and the slide will be just as support for that. So maybe I start here and go rapidly over this. So the index, so we know this here, this is a library, and it's like we could think that in when it's a computer, when you want to search data in a computer, then it all goes fast. But in fact, like if you have massive amounts of data, massive amount of text, then it's not that fast if you go over the entire corpus every time you look for something. So the same mechanism is like, so Elasticsearch is basically mimicking this this mechanism here. You have an index where this word is in this document, and that makes it all much faster. So this is like in the core, that's Elasticsearch. And I think one of the other parts also of Elasticsearch or of the full text search is that our language is ambiguous. So we have different forms of words. We want to match them, so we cannot really compare exact the same tokens. We have maybe synonyms, and we have maybe words that we want to split. So all this kind of, let's say, difficulties with our language, when you use a full text search engine like Elasticsearch, it helps you cope with all those problems, all this kind of problems. And and here, of course, Elasticsearch can be also used as a, let's say, as an NoSQL database or as a solution for monitoring, and there's lots of other solutions, but here it's only about the search. And so, but the core of the problem is this big company here, or small company. And so they showed us that it can be really painless. So you can easily find some stuff. You don't have to type it exactly the same word. So they showed to everybody in the world that search doesn't have to be painful. And I think that's the reason why when you build a new application, when you build an application, you want to provide a search, everybody expects it to be super easy, super fast, and understand what you want, even though you don't type it. That's because of those guys here, and they make it like really, let's say, interesting for all of us to work on these topics. And so very often when I speak to people, they say, but look, why is it not working? Why is your search not that great? Because like when I go to Google, I type whatever, they find the right thing. But of course they have a few other guys that work on this topic, so it's not just a dozen of engineers. So yeah, this is like in German, but yeah, it's like, but maybe let's go to this slide here. So when you think about full text search, what you have, like you have two, let's say, sides of the problem. So one side is like you have documents, on the other side you have the queries. And so what happens is when you have a document, so for example here, the document is composed just of one word, Wanderausrüstung. You analyze this document and you store the token somehow in Elasticsearch or full text search, and then you can store many documents. And on the other side, you have the queries. And that's, you have, for example, here the query was zum Wandern, and you have the query analysis, and it also produces the tokens based on this query. And then finally what you do is, like in the core of it, You compare those tokens, and you can say how similar is my query to the document. So this is like the basic mechanism. Do you have questions so far? Okay. And so then, of course, the different, let's say, processing pipelines, they have different steps. And so you have, so in Elasticsearch, you can build the pipeline, how you process a document or how you process a query. You can build it yourself. There are some nice, let's say, preset defaults, but you can define all the pipelines yourself. And what's even important is you can define a different pipeline for indexing the document and for querying, which is sometimes really important. But these are maybe somehow some important steps of such a pipeline. So you tokenize a text. So you have to, like you have an entire document, you split it into tokens. Very often a token is a word, but it might be also 2 words. Or for example, as I said, like my product ID. So there I don't split on the points, but I get rid of the points. So these are different kinds of tokenizers. Then what we have is like in natural language, we have the different forms of words. So for example, to sit or sitting, all that stuff. So to make like the core form of a word, that's called stemming. And then we have topic like stop words that don't include anything in the, like don't add anything as information. So we can get rid of stop words. But currently this is not really true anymore because it's like you don't have to optimize it that much. So sometimes keeping stop words might be a good idea. For example, if you think of to be or not to be, that's all stop words. If you get rid of that, you will not be able to find it. And then some specific parts like decomposition and synonyms. And so just to make it really quick, I just have an example of what happens with a query. So here I have the query that says suche spannende Routen zum Wandern und Velofahren, and so this you see what happens with this phrase here. So we have the step here where you do tokens out of this. So we have the different tokens. Then you do lowercase so that the word was uppercase and lowercase, like it really matches. So you can reduce that all to lowercase. You get rid of the stop words. You produce the stem of the word. So out of Velofahren, you produce Velofahr. And then in German language, we have the specific part, the specific topic that words can be composed. So we have to decompose them in order to find it. So here we decompose Velofahr into Velo and Fahr. And then if you apply synonyms, you have like Velo and Rad. And finally, this tokens here that you see here will be stored in the index. So whenever you have a query that looks, for example, for Such and Wander, you will probably find this document here. And so that's so what happens here with this word here, zum. We just skip it when it comes to the stop words. So that's why it's not indexed at all. And then, so we have all indexed all these documents, but what happens now? We have to somehow get this data from the index and somehow match it to our query. And there are also some, like, let's say, complications and topics that we have to think of is, like, when we have a query, and we have matching documents. So we have a document that matches a lot and a document that matches less. So we have to take care of how we order these results. And this is also something that a Fulltext search engine takes care of or helps you with that topic. So what's the ranking of the documents? And then you have topics like how can you measure the quality of the queries. So it's like we write unit tests when we write our code, and in case of a search you can maybe that's not really a unit test like when it's the quality, but you can somehow there must be a way to measure the quality of your search of your indexing. And so, and maybe I will fast forward to this here. So I was mentioning like what are the different ways of how you can measure the matching of the document with your query, and define the ranking. So you know some of them. So Google works with the page rank. So the page that gets a lot of like incoming links is deemed as more important. And the basic mechanism that is used for Fulltext search is this TF-IDF. This is the term frequency, inverse document frequency, which just tries to understand like how many times does a term appear in a document. and how many times, like, or is this term like somehow discriminating the documents when it compared to other documents. So I did it somehow in a fast forward way, but maybe like, do you have questions when it's like to what I just presented here? Was it like, yeah? For normalization. Yeah. So you mean normalize it like you want to do stemming and you want to do. So that's in fact built in Elasticsearch. So you have different stemmers there. You can normalize the text. Yeah. So that's exactly the parts that you don't have to take care of. So if you take Elasticsearch install. Yeah, exactly. And there, what you can do is like you can, for example, you can define which stemmer you want. So they are more aggressive and less aggressive stemmers. So the less aggressive stemmers will cut a smaller part of the words. But then, so that means that the precision is higher, but maybe the quality, like the quality is higher, and maybe you get less results. So these are some choices you have to do. You can do, but it's like basically all the things that I described here. This is covered by Elasticsearch. So I think that that's a good question, and I would say that no, because like Elastic just indexes documents and not the relations between documents. So this is just a list of what are the known algorithms to do some ranking, but it's like it's not. Okay, so this kind of stuff, you can boost certain fields. So for example, you can say that this field is more important than another field when it comes to a query. You mean in Elasticsearch, or? Yeah, I would say that all that is built in, but yeah, you can find easily the information. So how can I boost the fields? Or for example, there are some, if you want to like change the ranking of the results, you can have like function scores. So for example, when you think of a enterprise, like let's say a web page of a large company, you might say that all the documents that are higher up in the hierarchy, or like that's like less deep in the tree, information tree, they might be considered more important. So that you might.
I have to do this weights myself. I just once I found some matching by a guy who said, okay, it's a little bit Google-like done, and I would ask if there are any presets.
So when you think of Elasticsearch, more think of it, it's a framework that you can build on top. What we do as a company at the moment, we built a lot of that framework, but we start now more to build solutions, and it sounds you're much more looking for that. So for example, we have site search and enterprise search, and there it's exactly like you put in your data, there are some magical components in there that are going to do ranking and so on. You can put some buttons in to optimize it for your use case. You get less flexibility, but you have that out of the box experience. So it's kind of that trade-off. You want to have out of the box experience, you get less freedom. Or you want to have the full framework, you have to do it all your own. You have to do the work yourself.
So, but like I think that's an important point, and maybe we see it even here. But I don't know whether it's like so here. Where's my? I don't see. Maybe I have to go to the real code. So Elasticsearch is like a toolbox. So it comes with a lot of nice presets, so you can start right away. But once you start using it like for real, you will see that you have and can customize a lot of things. And one of the things is exactly like, for example, defining like, if I have a title of a document and I have a long text, so I can say whenever there is a match in the title, that has much more importance than when there is a match, for example, in the body of the document. And you can define that stuff. So I'll just see here, we'll probably just see it. Where is it? Model. Where's my boost? Yeah, it should be, yeah. But I don't see it here. Oh, that's why it's not working.
Is it downloading or only while you search?
Yeah, you can do that on search time as well.
Let's take this on afterwards also for a beer, I would say.
Can I ask one?
Yeah, of course, yes.
What do you use for decomposition?
So here currently I don't use any. Sorry?
Do you use like a dictionary or?
Yeah, that's also a good question. So here, for example, so here I don't use anything at the moment. So currently we don't do decomposition, but in my previous project that I was doing, like for a syrup that has been closed, it's like, so what we use is a like encoded tree. So it's like, it's not a dictionary that you have, but you have a library that has like this tree that is already like having all this decomposition, but there you have some fancy effects or like funny effects. Like for example, if you have a word, well, that doesn't appear in normal e-commerce sites, but like if you take the word Urinstinct, so how do you think, how does it decompose? It's Urinstinct. So you have this kind of funny effect. So
Is it based on like just on algorithms? Was it, or was it actually a dictionary that was like fed by human?
yeah, I think that probably you can have a dictionary and see like which of the words, like subparts of other words, so you can somehow generate this tree out of a lot of data. I think that's how it's done, but it's like,
German language is like really bad for that stuff.
no, it's a nice challenge. Okay, so if you have any other questions, I'm still here for a beer afterwards, and I will pass over to Nicolas to his talk.
Cool. Thank you very much.